The question is, consider the three processes P1, P2, P3. Process arrival time, time units required. P1 0, 5, P2 1, 7, P3 3, 4. The completion order when using FCFS, which is first come first serve, and RR2, which is round robin scheduling with time quantum 2 time units, are option A FCFS P1 P2 P3, RR2 P1 P2 P3. Option B FCFS P1 P3 P2, RR2 P1 P3 P2. Option C FCFS P1 P2 P3, RR2 P1 P3 P2. Option D FCFS P1 P3 P2 and RR2 P1 P2 P3. So first let us do the FCFS scheduling and see what the output is. So the way we do it is using a Gantt chart, so which is basically a timeline. So what happens is, at time 0 only P1 has arrived, so only P1 can execute. FCFS is first come first serve, so P1 gets the time slot execution time and it finishes its execution in 5 time units. So at the first time unit P2 arrives, at the third time unit P3 arrives, they are put into a queue, so P2 is in the front of the queue, but they do not preempt P1 because FCFS does not allow preemption. So the first in the queue is P2, so P2 executes next. So P2 needs 7 time units, so it finishes at the 12th time unit. Then P3 executes. P3 requires 4 time units, so it finishes at the 16th time unit. So FCFS order is P1, P2, P3. Now let us see the round robin scheduling. So in RR2, the time quantum is 2 time units. So we'll again draw a Gantt chart and check the order of completion. So now let us also maintain a queue, since that will simplify the process of solving this. So first at time 0 only P1 is there. So P1 gets the execution. So P1 can execute for 2 time units only, but at the first time unit P2 comes into the ready queue. So now P2 is in the queue, P2 is in the front of the queue. P1 is not preempted until its time quantum is over. So now PM's time quantum is 2 time units. So it finishes at the second time unit. So 5 out of 5 he has executed 2 time units. So now 3 is remaining. Now at the second time unit P1 comes out. P3 has not yet arrived. So P2 is given execution and P1 comes into the front of the ready queue. So P1 is at the front of the ready queue, P2 is given execution. So P2 executes till 4th time unit, but before that P3 arrives at the 3rd time unit, so P3 is enqueued. So still P1 is in the front. So now P2 executed 2 time units, so 7 becomes 5. Now P1 is in the front, so P1 is given execution and P2 is put at the back of the queue. So P2 is added here and P3 becomes the front of the queue. P1 is given execution. So P1 finishes 2 units of time, 6. So out of 3, 2 is over, so 1 is remaining. Now P1 is again put at the back of the queue. Let me just redraw the queue here. So P3, P2, P1, this is the queue where P3 is the front. Now P3 is given execution, so P2 becomes the front. P3 takes over here and it executes 2 time units. So it finishes at 8th time unit. Now out of 4, P3 has executed 2 time units. So remaining 2. Now P3 is enqueued back. Now P2 is at the front of the queue, it is given execution. P1 becomes the front. P2 takes over. P2 requires 5 units more, so it will finish its 2 units, since that is the time quantum. So 5 becomes 3. And now P2 is again enqueued. P1 is given execution. P3 becomes the front of the queue. Now P1 requires only 1 time unit, so it doesn't use its full quantum, so it uses only 1 time unit. So at 11th P1 stops execution and P1 is not pushed back into the queue because it has already finished its execution. So P1 is the first to complete. Let us also maintain a completion order, since that is the question. Now P3 resumes execution, and P3 requires to do 2 time quantum, 2 units required, and 2 units is the time quantum, so it will finish its execution at 13th. The rest is done by P2. So P2 finishes its execution at 16th. So the completion order is P1, P3, P2. So for FCFS it's P1, P2, P3. For RR2 it's P1, P3, P2. So this is right in option C. So option C is the right answer.